Wildlife conservation is an urgent global concern as numerous species face threats such as habitat loss, poaching, and climate change. Fortunately, advancements in technology have opened up new possibilities for wildlife conservation efforts. From remote sensing and data analysis to drone surveillance and DNA testing, this detailed exploration delves into the intersection of technology and wildlife conservation, examining the innovative solutions and tools that are being employed to protect endangered species and preserve biodiversity. Remote sensing and monitoring. Satellite imagery. Satellite imagery provides a bird's-eye view of ecosystems and helps conservationists monitor large-scale changes in habitat, deforestation, and encroachment. High-resolution satellite images allow for the identification of habitat loss, illegal logging, and the presence of human activities near protected areas, aiding in the planning and implementation of conservation strategies. Camera traps. Camera traps are motion-activated cameras that capture images and videos of wildlife in their natural habitats. These devices provide crucial insights into species distribution, behavior, and population dynamics. By collecting data on animal movements and interactions, researchers can better understand the needs of endangered species and develop targeted conservation interventions. Acoustic monitoring. Acoustic monitoring involves the use of specialized equipment to record and analyze the soundscape of ecosystems. By studying animal vocalizations and other environmental sounds, conservationists can monitor population trends, identify species presence, and detect illegal activities such as logging or poaching. Acoustic data can also aid in the identification of animal behavior patterns and contribute to conservation planning. Genetic and DNA technologies. DNA barcoding. DNA barcoding involves analyzing specific regions of an organism's DNA to identify species and detect genetic variations. This technique is particularly useful in identifying endangered species, confirming the presence of rare or elusive species, and combating illegal wildlife trade. DNA barcoding provides a robust tool for monitoring biodiversity and ensuring the accuracy of species identification. Non-invasive genetic sampling. Non-invasive genetic sampling techniques, such as collecting feces, hair, or saliva samples, allow researchers to obtain genetic information without disturbing or endangering wildlife. These samples can be analyzed for genetic diversity, population structure, and individual identification. Non-invasive genetic sampling provides valuable insights into the health and conservation status of endangered species. Genetic rescue and assisted reproduction. In cases where populations of endangered species are small and genetically depleted, genetic rescue and assisted reproduction techniques can be employed. These technologies involve collecting genetic material from individuals and using it to enhance genetic diversity through artificial insemination, in vitro fertilization, or cryopreservation. Genetic rescue and assisted reproduction techniques help mitigate the risks associated with small populations and improve the long-term survival prospects of endangered species. Monitoring and anti-poaching technologies. Drone surveillance. Drones equipped with high-resolution cameras and thermal imaging sensors can monitor vast areas of protected land, providing real-time information on wildlife movements, poaching activities, and habitat destruction. Drones enable rapid response to illegal activities, enhance anti-poaching efforts, and provide valuable data for conservation planning and management. Smart tracking and collaring. Smart tracking devices and GPS collars allow researchers to monitor the movements and behavior of endangered species. These devices provide detailed information on migration patterns, habitat usage, and potential threats. Real-time tracking data can help identify critical habitats, inform land use planning, and facilitate targeted conservation interventions. Artificial intelligence, AI, and machine learning. AI and machine learning algorithms can analyze large amounts of data, such as satellite imagery and camera trap images, to detect patterns, identify species, and even predict poaching hotspots. These technologies enhance the efficiency of data processing, facilitate rapid species identification, and assist in monitoring and anti-poaching efforts. Public engagement and education, virtual reality, VR, and augmented reality, AR. VR and AR technologies offer immersive experiences that allow people to virtually visit protected areas, engage with wildlife, and learn about conservation efforts. These technologies provide educational tools that promote awareness, empathy, and support for wildlife conservation. VR and AR experiences can also serve as fundraising tools, attracting public support for conservation initiatives. Citizen science and mobile applications. Citizen science projects and mobile applications enable the public to contribute to wildlife conservation efforts. These platforms allow individuals to report sightings, collect data, and participate in monitoring and research initiatives. Citizen science projects empower communities and engage a broader audience in conservation, fostering a sense of ownership and responsibility for the protection of endangered species. Conclusion: harnessing technology for wildlife conservation. The marriage of technology and wildlife conservation offers promising solutions to the pressing challenges faced by endangered species and ecosystems worldwide. Remote sensing, genetic and DNA technologies, monitoring and anti-poaching tools, and public engagement platforms are revolutionizing the way we protect and preserve biodiversity. By leveraging these innovative solutions, conservationists can gather critical data, identify threats, and implement targeted interventions to ensure the survival and recovery of endangered species. However, it is crucial to acknowledge that technology alone cannot solve the complex issues facing wildlife conservation. Effective conservation requires a holistic approach that combines technology with policy changes, community involvement, and sustainable practices. Collaborative efforts among governments, researchers, local communities, and conservation organizations are key to implementing long-term conservation strategies that safeguard ecosystems, protect endangered species, and promote a harmonious coexistence between humans and wildlife. As technology continues to evolve, it is imperative to embrace innovative solutions while maintaining ethical considerations, respecting local communities, and prioritizing the welfare of wildlife. By harnessing the power of technology and fostering a collective commitment to conservation, we can pave the way for a sustainable future where endangered species thrive, biodiversity flourishes, and the beauty of our natural world is preserved for generations to come.